Hi, in this particular playlist we're going to be looking at the foundation tier for Edexcel, and this is actually paper 2, which is the calculator paper. And if you follow the link below in the description, you'll be able to download and have a go at the questions for yourself. The whole idea is I'm going to break the whole paper down into videos of about 20 to 30 minutes, have a go at each of the questions and then compare your solutions. I hope it's okay for you, and we'll move on then to question 1, okay, which deals with writing down the value of 3 in this particular number. Okay, well, beginning of this particular paper, most of the questions are relatively straightforward, but let's just make sure that we do all of the questions. So I've got 3 in this, that's going to be 300. If you imagine, that's 4,376, so the value is 300. Okay, let's move on then to write 7/16 as a decimal. Well, this is a calculator paper, so if you feed this into your calculator, what we're basically saying is what's 7 divided by 16. Remember that with a division, what that means is put that 7 here and put that 16 here. It's exactly the same as a fraction. So 7 divided by 16 in a calculator is 0.4375. Okay, and then question number 3, here is a list of numbers, and from the numbers in the list, write down a cube number. Okay, well, a cube number is, there's actually 2 on this list, one of which is 27, the other which is 64. You can use one or the other, it doesn't really matter, because 27 is 3 times 3 times 3, which is 27. Okay, and 64 is 4 times 4 times 4. If you put that in a calculator, you'll be able to work that out. So you can choose one or the other, it doesn't really matter. I'm going to choose 27 on this particular question. Okay, on to question number 4, and it says find the value of. Now, you just got to be really careful with this, because essentially calculators will only do what you ask them to do. Okay, they don't really understand concepts like BIDMAS and that sort of thing. And that's the important thing with this, is that you've got to make sure that you're following things in the correct order. So with brackets, you always do whatever is in the brackets first. So if you calculate 2.8 minus 0.45, what you actually get is 2.35, okay? And then what we're going to do is square that, which is this squared here, and then we're going to plus the cube root of 5.832. Okay, if you feed that into a calculator, you're going to get 7.3225. Okay, and that will be the answer to this particular question. Now, the difficulty with this and with this is that you have to make sure that you know where the keys are. So if you're not sure about that, please do have a look at some of the playlists and some of the information on working with scientific calculators, and you will need a scientific calculator for most of these questions. You could kind of do it with the standard one, but it would take quite a little bit of time, and I'm not entirely sure whether cube roots would be on a standard calculator. You'd probably need to make sure you've got a scientific one for that. If you're in any doubt, have a chat with your teacher and see if you can find a way of getting a lesson or getting some overview of how scientific calculators work for you. Okay, let's move on then to question number 5. And question number 5, it says there are boys and girls in a classroom. Okay, and what we're being asked to do is that it says the probability of picking at random a boy is 1 out of 3. Okay, so you remember before in a previous video I might have said, in fact I usually do, is that this should be read as 1 out of 3. Okay, so what that means is the probability of picking a girl would be 2 out of every 3. So out of every 3 people that there are in the room, 1 of them is a boy, 2 of them are girls. So the probability of picking a girl is going to be 2 out of 3. Okay, then let's look at question number 6. A little bit wordy, this one. And it says Jan writes down one multiple of 9. And as before, when we're looking at word questions, I think it's always a good idea just to do something with the first little bit of it. And what I'm going to do is I'm going to write 9, 18, 27. Those are all in the 9 times table, okay? And then she also writes down 2 different factors of 40. So this here is, the first bit is multiples of 9. And then what I'm going to do is I'm going to write out factors of 40. And you'll remember that factors of 40, what that's all about is making sure that when we look at the number 40, it's the numbers that will divide into 40. So those numbers are 1, 2, 4, 5, 8, and you really need to know your times tables for all of this, because 2 times 20 is 40, and 4 times 10 is 40, and 5 times 8 is 40, and 8 times 5 is 40. Also, we can put in 10, 20, and actually 40 itself, because 40 will go into 40 once. Then it says Jan adds together her 3 numbers. So in other words, she adds one multiple of 9, so let's say it could be 9, and then 2 different factors of 40. So she could add 9, 1 and 2, which would make it 12. However, we're being asked to get an answer which is greater than 20 but less than 30. Okay, if that is the case, then we need to choose our numbers a little bit carefully. So what I'm going to do is I'm going to choose 18, which is the 1 multiple of 9, because that's going to kind of get me quite close to 20. And then if I add 2 and I add 4, I've got actually 18 plus 2 plus 4, and that equals 24. Well, that's a number which is greater than 20 but less than 30, so that'll be absolutely fine. For answering this question, it could have been 18, 2 and 4. It could be a combination of another number of other ones, and perhaps you could have a go at finding some alternative ones as well. Okay, so let's move on then to question number 7. Now, question number 7 is a little bit trickier. And basically what we've got here is something that just makes it look, oh, I don't know, a little bit more tricky. But basically what we're trying to do is we're saying that we need to work out the fraction of the square which is shaded. Okay, so in other words, as we've said before, fractions are all about how many out of how many. Okay, well, the smallest square we've got here is this little square here. So what I'm going to do is I'm going to be just a little bit cuter with this, in that I'm just going to take my time to divide this whole thing up into a series of squares which are the same size as this little one here. Okay, now I hope this is going to come across okay on the video, but what we're trying to do is trying to give you methods and ways of dealing with these questions that will just make your life a little bit easier. Now, I could get very mathematical and I could sort of give you a way of adding all of this up, but what I think would be easier is actually if we say that it's something out of something, what we've got to do is we've got to figure out how many little squares there are all together. Well, it's 8 along here and 8 down here, so 8 times 8 means that this would be 64 squares. Okay, so there's 64 little squares on that. And then we've got to kind of figure out how many squares are actually shaded. Well, I could count every single one. 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. Or I can actually say, well, if I look at this, there's 11 squares which are not shaded. So that means that 64 take away 11 is 53. So 53 of them must be shaded. So actually it would be, the fraction is 53 out of 64, okay? So it's a kind of a fairly straightforward approach, very pragmatic kind of approach to these sorts of things. But you could write very happily 53 out of 64, and that would be absolutely correct for this question. Okay, hope that's all right for you. Let's move on then to question number 8. Okay, in question number 8, these are becoming a bit more popular with these sorts of papers where they give you a graph and they ask you to write down 3 things which are wrong with the graph. Well, it's actually quite a nice looking graph. I think he's done a good job. The problem is that we don't know which is Sam and which is Max. So he actually needs a key. So it needs a key. So there's 2 different colours. We don't know who is who. Okay, so it could be this is Max and this is Sam, or it could be the other way around. Okay, the other one is that we've got on the left-hand side, we haven't got a label. And always with these, we need to make sure there's no label. Now I'm going to call it the y-axis. Okay, which just basically means this particular line along here. So there's no label there. Now, if you're looking at that very carefully, they've also been a little bit sneaky as well, because actually the number 4 is missing from there. Okay, so 4 is missing from the y-axis. Okay, so you've got to be a bit careful when you're looking at that. And very typically with these sorts of questions, that's the kind of way in which you would be able to answer these. Do look for missing numbers, look for missing labels, and also look for some way of differentiating between the 2 people on this particular graph. Okay, so let's move on then to question number 9. And it says here is a list of numbers, okay? And what it says is that we need to find the median of these numbers. Well, median is just one of these maths words that basically means middle. And the way that we do that is we put all of these numbers in order and then we figure out the middle ones. So I can write out 11. There's number 11 here, and then I've got 2 12s. No, actually I've got 3 12s, so it's 12, 12, 12, and then I've got a 13, I've got 2 15s, I've got a 17, and I've got a 19. Okay, so I've put them all in order, and to figure out the median, the middle number, I just basically work my way through, and what you'll find is if you knock off these up at the end, that number 13 is actually the median value. So I can answer this at saying the median is number 13 there. Okay, hope that's all right. We're on about 12 minutes into the video. What I'm going to try to do is make this video, as I mentioned before, about 20 to 30 minutes in length. And I hope you have been able to work through the paper, print off all the paper and have a go at it and make sure that you compare your solutions. Okay, on the post on 3 Minutes Maths, you'll be able to also download the mark scheme so you can have a look at how marks would be awarded. Okay, so question 10. What we're doing here is writing an expression for the total number of packets of crisps that Rob buys. Okay, so he buys some plain crisps and some cheese crisps. So he buys some plain and some cheese. Okay, it's P packets of plain and C packets of crisps, of cheese crisps. So the total amount that he buys is T equals P plus C. Sometimes these questions can be a little bit tricky. Do have a look on the website on 3 Minute Maths and you'll be able to download some questions very similar to those that you can have a go at for yourself. Okay, so we're going to look at question or part B, which is 3x minus 5 equals 9, and we've been asked to solve it. In other words, find the value of x. So what we're going to do is we're going to balance everything around the equals sign and find a way to get x's on one side and numbers on the other. So in this particular case, this minus 5 kind of doesn't fit for me. So what I'm going to do is I'm going to add 5. Because if I do that, I'm going to take it away. I'm going to get rid of it because minus 5 plus 5 is 0. But because we've got to balance it, I've got to do it to both sides. So what we end up with is 3x equals 9 plus 5, which is 14. Okay? Now that's 3 lots of x. So to get 1 lot of x, what I need to do is divide by 3. So if I divide this by 3, I get x on its own. And on the right hand side, if I divide by 3, I actually get 14 over 3, which is sufficient to answer this question. You can just absolutely leave it at that, and that would be perfectly fine. You can write that in the answer book and you'll still get your full marks. However, if you prefer to turn it into a decimal, just use your calculator to work out 14 divided by 3, and you're going to get x equals 4.6 recurring, okay, which is 666666 forever and ever. So you can put, if you prefer, or 4.6 recurring. Okay, hope that's all right for you. Let's then move on to question number 11. And question number 11, we've got a statement, which is when you multiply an even number by an odd number, the answer is always an odd number. Okay, so let's just look at that. So if we've got an even number, so there's an even number, well, let's say 2, okay? And we're going to multiply it by an odd number, well, let's say 1. Well, 2 times 1 is 2. So in this particular case, it's wrong because that's actually an even number, okay? Let's just do it one more time for the sake of completeness. So we've got an even number. I'm going to use 2 again because it's just a bit easier. And I'm going to multiply that by an odd number, and let's just say 3. So 2 times 3 is 6, which is an even number. Okay, so this is not correct. Okay, right. So then Betty says, when you multiply 2 prime numbers together, the answer is always an odd number. Betty is wrong. Explain why. Well, let's just have a look at that for a minute. So if we say 2 prime numbers, say 3 times 3, well, that's 9, which is an odd number. So it looks on the surface that Betty is correct. Well, actually, she isn't entirely correct, I'm afraid, because there is one particular prime number, which is the number 2. And as we've seen before, when you multiply an even number by an odd number, like 3, you're actually going to get 6, which is going to be an even number. Okay, so actually, because 2 is a prime number, Betty is wrong, because any number you multiply by 2 is going to be even. And you can just try that for yourself. So let's say, well, let's think about 2 times 11. 11 is a prime number because it's not divisible by anything but itself and 1. So 2 times 11 is 22, which is an even number. Okay, we'll try 2 times 7, which is 14, also an even number. Okay, so it's because of this number 2 being a prime number and an even number, it's the only one that there is, then the effect is that it's always going to be an even number at the end. Okay, so we're on 18 minutes. Let's just have a look at question number 12. And question number 12 deals with a conversion graph. Now, I hope this is going to show up okay on the video, but basically what we're doing is drawing a conversion graph to show miles and kilometres. So really all you need to do is plot the points. So let's just have a look at that. Okay, so the first point, if we look at the top, is going to be 0 miles is equivalent to 0 kilometres. Okay, so that point is going to be 0, 0 at the bottom here. Okay, now I've got a bit of an issue because there is no key, there's no information about where these kilometres are on the left hand side. Okay, so there's a bit of a tip here. What you can do is, I know from the grid that I need to make my maximum amount 64. Okay, well, let's say 60 just for the sake of argument. Okay, so if I wanted to, I could just draw a very, very small graph where this is 10, 20, 30, 40, 50, 60. You can see here my graph would actually be that tall by this wide. Okay, so it'd be just that tall. Okay, well, it's not going to look great really, it's going to be all right, and you'll probably get the mark. I think there is actually 3 marks for this. So I suspect that what they want you to recognise is that actually, because it's such a tall amount, or quite a good amount of graph paper, that you can make it so that this is 10, this is 20, 30, 40, 50 and 60. So in other words, use 2 of these blocks per jump of 10. Now in actual fact that'll make it easier, because it means one of these little squares is actually just 1. So this is 21, 22, 23, 24, 25, and then 26, 27, 28, 29, 30. So actually that's going to be a little bit easier for me to plot. So I started with 0, 0 right at the very bottom here, okay? And then what I need to do is I need to plot 5 to 8. So it's going to be 5 miles to 8 kilometres. So if I come along the bottom here, I got 5. And then if I put my point there, it's going to be 8 kilometres. Okay, and then the next one is going to be 20 and 32. So 20 and then 32 will be here. And then finally I've got 40 and 64. So 40 and then all the way up to 64, which is going to be there. And what you'll find is that actually this is going to make a straight line. So what I can do is use my ruler, and then I can create for myself a nice conversion graph that will actually go on and on forever and ever as a direct conversion. Okay? And then to ensure that you're getting this correct, they ask a supplementary question of part B to this, which is further, 20 kilometres or 15 miles. Well, what we need to do is we need to convert this 20 kilometres to 15 miles, to the amount of mileage that it is. So if I look on my graph, 20 kilometres, if I take this across and then take this down, okay, now what I've got there is actually, this is 13 miles. Hopefully you can see that, 13 miles. So actually in this particular case, 15 miles is further. Okay, and that would be the answer to part B of this question. Okay, I hope that's all right for you. This is 22 minutes into the video. I think we'll do one more question, if that's okay, which is going to be question 13, and then we'll stop at question 13, and then we'll look at the next video starting from question 14 onwards. The reason I've done that is because question 13 does take a little bit of working, but hopefully you'll be able to work this through. The main thing about it is it says give a reason for each stage of your working. What you're trying to do is prove that this is an isosceles triangle. Okay, well, let's not worry about that too much at the moment. Let's see what information we've got. Well, we know this is 80 degrees. So therefore this is 80 degrees, okay? And what I can do is I can write as a proof that if I have two opposite angles, so I can put here opposite angles are equal, okay? And that's the first stage of my proof. So I know then that I can put this as 80 degrees here and this is 50 degrees, which we're told. Okay, let's have a look at another one then, is that if we know this is 80, we know this is 50, we can work out this. The reason we can do that is because the internal angles of a triangle add up to 180 degrees. So if this is 50 and this is 80, okay, what I can do is I can say, well, 80 plus 50 is 130, and then to work out the value of C, well, I'm going to take 130 away from 180 and I get 50 degrees. So C must be 50 degrees, okay? So therefore I can say that angles in a triangle add up to 180 degrees. Okay, and then the final little bit, if we have a look at this, what we've got is two angles at 50 degrees and one angle at 80. Okay, so if I just draw that the other way around, what I've actually got is two base angles at 50 degrees and one angle at 80 degrees, and therefore A, B, C, which is just the same as this one here. I've just tilted it round the other way. We can say that it must be an isosceles. Okay, alrighty, so I hope that's okay for you, you're able to follow that through. So we're going to leave the video there at 25 minutes. I'll move on in the next video from question 14 onwards. I hope it's been useful to you. Please don't hesitate to leave a comment below if you're not sure about anything. Have a look through the channel and have a search for some of the other topics. If you're not sure, you should be able to find some videos on some of these topics. Please do subscribe to the site, and I'll look forward to seeing you inside the next video.